Good day, friends. Welcome to my channel, lecture series on power electronics. In this lecture, we will see what is back EMF. A DC machine looks as shown in the figure. There is a field winding in the stator and there is a armature winding in the rotor. This is the commutator, and whether it is a DC motor or a DC generator, the parts are the same. For ease of understanding, the motor is shown in the picture like this and the generator is shown like this. In the case of a motor, the input is electrical energy and the output is mechanical energy. Here we see the stator with the poles and the rotor with the armature winding. Normally, the input electrical energy is given to the armature, and in the presence of the magnetic field, the motor generates a torque and it rotates. Whereas in the case of a generator, a prime mover is used which provides the mechanical input to the armature, and when the conductor works in the magnetic field, it produces electricity and gives it back to the source. So this is the principle of a motor and this is the principle of a generator. In the case of a motor, the input is electrical energy. Because the conductor is rotating in a magnetic field, it produces a torque. And in the case of a generator, the input is mechanical energy provided by a prime mover. It can be a windmill, turbine, or any other source which can give a mechanical input to the armature. So when a conducting material moves in the magnetic field, it produces electricity as shown in the picture. As already mentioned, any conducting material rotating in a magnetic field would produce electricity. So in the case of a motor, when electrical energy is given as the input, it starts rotating. When the conductor is rotating, it is rotating in a magnetic field. So as per the principle, it has to produce electricity and give it back to the source. So in nutshell, when a motor is rotating, the armature rotating in the magnetic field would generate electricity and it is given back to the source, that is called as the back EMF. It will be opposing the supply voltage given. So this induced voltage E, that is the back EMF, and the supply voltage V will be opposing each other. A shunt motor is shown in this picture. The value of back EMF is given by the equation similar to that of a generator, where this back EMF depends upon the number of poles P, the flux inside the machine phi, and the speed at which the armature is rotating. Z is the number of conductors, A is the number of parallel paths, and this is also given by this equation EB is equal to V minus IARA, where V is the supply voltage, IA is the armature current, RA is the resistance of the armature. So when the motor is generating an EMF, the voltage which is available at the terminals is after the drop in the armature is IARA. Back EMF is given by this equation, EB is equal to V minus IARA, and it's also given by this equation, P phi N by 60 into Z by A. To summarize, to compare a DC motor and a generator, for a motor, the input is electrical energy and the output is mechanical energy. For a generator, the input is mechanical energy and the output is electrical energy. Basic principle of a generator is that when a conductor moves in a magnetic field, it generates electricity. Basic principle of a motor is that when a conductor placed in a magnetic field is provided with electrical energy, it produces mechanical energy. So back EMF is defined like this. A motor has coils turning inside magnetic fields and a coil turning inside a magnetic field induces an EMF. This EMF is known as back EMF and it acts against the applied voltage that is causing the motor to run. Induced EMF acts in opposite direction to the applied voltage as per Lenz's law, and that is known as back EMF or counter EMF. So in this lecture, we have seen the comparison between a motor and a generator operation and the definition for a back EMF. Hope this clarifies what back EMF is. Thank you.